Solve the inequalities. All right, so in the first one, we have x squared minus 8x plus 7 is less than 0. We're trying to show where that's true, right? So first thing I want to mention is that there are at least 3 or 4 kind of accepted methods to solve these type of inequalities. I'm going to show you what I think is the simplest approach, and the one that I feel like students get easier. However, you may find that there are better approaches you like better. Some people test regions of the x-axis, and that's fine and well. You can do that. For me personally, I feel like looking at a graph is very visual. I think that we've mastered graphing in other sections, so at that point, assuming that you've got that down pat, then it should be very easy to graph the functions, and once you graph them, the solution is very visual. The first video in this section shows how to use a graph to determine these regions, so I feel like the graph is actually the best way to go. So we're going to do it that way. However, if you see other procedures where they're testing regions of the number line, that works perfectly fine too. It's just that for most people, I think that's slower and harder to understand. So let's look at part A here. And basically, we're going to try to graph this function. The way we're going to do that is we're going to find the zeros of the function. So to find zeros of a quadratic, remember, you just set the quadratic equal to 0. So we're just going to say x squared minus 8x plus 7 equals to 0. And then from there, we will go ahead and factor that. If it's possible to factor, often it is. So in this case, we're looking at factors of 7 that add to 8. Well, that'd be 1 and 7, so that's factorable. So we'd have x and x. Remember, because it's positive here, we're going to have 2 of the sign there on the left. That's 2 negatives, and it'll be 1 and 7. Then we apply that 0 factor property, which says basically that we can separate these and set them equal to 0 by themselves, right? And that means that x is equal to 1, and that means that x is equal to 7. So those are the zeros of the function, or that's where the graph crosses the x-axis, right? So the solutions or the zeros of the function. Now from here, we want to also figure out where the vertex of the function is located, and we want to think about where the function, whether the function opens up or down. But that should be obvious. Remember that the function will open up if the number or the leading coefficient in front of x squared is positive. In this case, it is positive, so I will say that the function is going to open up. And from there, we just need the vertex. You don't actually even need the vertex, but we can identify the x-coordinate of it so easily, it's worth it to have it. But if we know that, for example, the x-coordinate of the vertex, which I'm going to call h here, so I'm going to say x-coordinate of the vertex, and that's equal to h, and that's equal to negative b over 2a. Remember that? So negative b in this case will be the opposite of 8, or negative 8, so we'll call it 8. And then 2 times a is just 2 times 1 in this case. So that's going to end up giving you 4. All right, so with these 3 points, we can get a reasonable idea of the graph of the function. So we're going to basically draw a little rectangular coordinate system here. It doesn't have to be anything fancy, just something simple to plot the points that we have. And we have 1 and 7 as our intercepts, so it looks like at x equals 1, right? Remember, this is your x-axis. Then we'll go out to 7 as well, so then it'll be 2, 3, 4, 5, 6, 7, so about there, right? And then the x-coordinate of the vertex occurs at x equals 4, so 1, 2, 3, 4, somewhere over here. Now, we don't know where that occurs on the y-axis. We could determine it by plugging into the function, but it doesn't really matter, does it? I mean, ultimately, it's somewhere down here, we'll say, because we know that the graph is going to open up. Now, we know it opens up because it's positive, right? The coefficient is positive, x squared, the leading coefficient. So because we have a positive x squared minus 8x plus 7, right? Then we know this function is going to open up because the number in front of it is positive 1. All right, so with that in mind, regardless of where that actual vertex occurs, and if you wanted to figure out where it occurs, we could just plug in the 4 into the function. Let's do that actually. It'll be 4 squared, or 16, minus 8 times 4, which is 32, plus 7. So that, of course, gives you negative 16 plus 7, and that, of course, gives you negative 9. So I'm a little off on where I drew it. It actually needs to be all the way down to negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should actually be way down here. But regardless of that, it still doesn't change the fact that it opens up. And the reason why it doesn't matter is because keep in mind that we're only looking for the simple question of, where is the function less than 0? And remember, anything below the x-axis will be less than 0. That means anything down here is less than 0 because that's below the x-axis. So we're talking about basically the region between these two x-intercepts, right? So we're talking about from here to here on our drawing. And where does that occur? Well, we know it occurs at x equals 1 and x equals 7. So that means the answer to our question is basically that from 1 to 7 on the x-axis, we will have values for the function that are less than 0. And we use round brackets around the 1 to 7 because we're not including those values. So this is the solution to the problem. All right, let's look at question B then. It says x squared plus 5x is greater than 0. So we can certainly solve that one by finding its zeros and graphing it. If you want to find the zeros for this one, it's actually pretty easy. It's x squared plus 5x is equal to 0. Then we'd factor out the x value, leaving you x plus 5, right? And that's therefore equal to 0. And then from there, the zero factor property says we can say that either x is 0, right? Either this one is 0 or x plus 5 is equal to 0, which gives you that x is equal to negative 5. So the zeros for your function are negative 5 and 0. Remember, the vertex for the function can be found by first starting with the h part, which is negative b over 2a. And for us, that's going to be negative 5 over 2 times 1. So in other words, negative 5 halves, right? So basically 2.5, so negative 2.5. So I'll write that in as negative 2.5. And then if you want to plug that into the function, you can actually do that. You can plug in 5 halves to your function and see what you end up getting. So in other words, if you plug negative 2.5 in for x in our original function, you'll end up getting negative 6.25 if you write it as a decimal. So again, that's your vertex of the function. And we don't really need, again, as I mentioned before, we don't really need the y-coordinate of the vertex because most of the time we're doing something simple like greater than 0, less than or equal to 0, that sort of thing. And so with that, we just need to know roughly where the vertex is located, whether it's above or below the x-axis. And you can figure that out by, again, paying attention to the leading coefficient. In this case, the function is x squared plus 5x, right? And if that's the case, then the x squared being positive means that it's going to open up. So we know this function will open up. All right, so let's draw our graph using a simple rectangular coordinate system here. And we can start by plotting the vertex, for example, negative 2.5. So 2.5 might be over here, and down 6.25 is 1, 2, 3, 4, 5, 6, 6.25. So somewhere around here is where the vertex is located. Remember, the function is opening up, and we found that the zeros of the function are at negative 5 and 0, right? So there is a 0 right here and at negative 5. So 3, 4, 5 puts us about here. And so our graph looks basically like this, right? Again, not the best drawn parabola there. It's supposed to be a nice U-looking shape. Let me redraw that just to make it look a little bit better. Okay. Whatever, it doesn't really matter that much. The drawing doesn't have to be perfect. But we're asking the simple question for the function, which is where is the function greater than 0? In other words, where is it above the x-axis, right? So greater than 0 means all the places above the x-axis here. And it looks like over here on this part of the x-axis, the graph is above 0. And it looks like over here on the x-axis, the graph is above 0. And so how would you describe those parts of the graph? Well, it looks like it's from negative infinity, right? Up until you get to that point. Well, where is that point occurring? Remember, that's negative 5. That's our 0, right? And then it looks like on the other side, it goes from 0 and continues on to positive infinity. So the question is whether we should include the 0 or not, right? And whether we should include the negative 5 or not. Well, I would certainly say that we would include it if it has an equal to sign, if it said greater than or equal to 0. But since those are equal to 0 and we're asking for where it's greater than 0, we're going to round those off, right? And then we just put a union between them to finish our answer. So in other words, our final answer for this problem is from negative infinity to negative 5, union from 0 to positive infinity. And that's it.